All right. So this is just an extension assignment. So we're just looking at naming compounds and using polyatomic ions. Polyatomic ions are covalently bonded together, and these molecules have a charge, and we treat them as a single unit. So when we were forming compounds with metals and nonmetals and nonmetals and nonmetals, we just treat the polyatomic ions themselves like another unit. And there's basically not going to be much of a change here. So here's a table with the common polyatomic ions, and they include the chemical formula, the name, and the charge. And you'll notice it's exactly what you would expect. The formula indicates the charge, right? And then um, you have the name. So nobody expects you to memorize these, but you would be provided these. You should be able to come up with balanced chemical formula and understand the names. All right, so a couple of things you might notice just looking at this, there are some patterns. So first of all, you notice that some of these have ite, ite, and ate at their names. And all that tells us is that the ite or ite has fewer oxygen atoms. Doesn't, if you look at the pattern, you might think, oh, it means 3 versus 4. It doesn't necessarily mean that. It just means that one with ite has fewer oxygen atoms. So you can see phosphite, phosphate, right? And you can look at a few others, right? Chlorite, chlorate. That's an example where it's 2 and 3. Okay, and we indicate the charge the same way. Most of these are negatively charged. Here, ammonium is actually positively charged. Okay. The other thing you'll notice is that some of these have hydrogen atoms, and the hydrogen atoms are actually hydrogen ions that have bonded to the molecule. So, for example, hydrogen phosphate, right? If you look at the phosphate, you'll also notice that the hydrogen ion changes the charge, right? So the presence of that hydrogen atom increases the charge from -3 to -2. Again, these patterns aren't necessary, but they kind of help if you ever find yourself studying chemistry later on, if you notice some of these patterns, so you can kind of follow along a little easier. So the naming rules, we're naming ionic compounds with a polyatomic ion, okay? So if we're looking at a cation and a polyatomic ion as the anion, it's really similar to what we were learning earlier. We take the name of the cation and then we add the name of the anion. We don't change it to IDE. This doesn't become hydrogen carbonide, right? It's just sodium hydrogen carbonate. And if you look on the table, HCO3, right? Hydrogen carbonate, right? That's just the name. So you're literally just looking it up on the table and then adding those together. The same process for the chemical formula. We have to make sure that the charges balance. So if we have the sodium as our cation and then hydrogen carbonate as our anion, right? Sodium starts off with 1 valence electron. Hydrogen carbonate, right? If we look at the table and scroll up, hydrogen carbonate here has a -1 charge. Okay. So what ends up happening is, right, this electron is going to transfer and it's going to form an ion, right? So it's still an ionic molecule. Now the charges balance out, right? Has the negative charge. So when these two come together, the positively charged sodium ion with the negatively charged polyatomic ion gives me a net charge of 0. Same process. Similarly, I included this example because this is where it gets a little bit different, but pretty much still the same. Let's look at magnesium hydroxide. So we start with magnesium, right? Magnesium forms an ion, right? We want to balance it out. Go back and look at our table for hydroxide. hydroxide carries a -1 charge. So if I go to balance this, 2 plus -1 leaves me with 1. So what am I going to do? So I need 2, right? I need 2 of these. So go ahead and write this. Now you would think, there we go, we added a 2. That's not right, all right? Remember, we have to have all of our ratios match up. We have to have the charge match up. It's not that I have 2, I need these parentheses to indicate that I have 2 hydroxides. In order to get to this balance, I need 2 of these guys that have the -1 charge, right? That gives me the 2, and then that balances it out, okay? So you have to make sure you include these parentheses, and that's really the only difference when working with the polyatomic ions, right? So let's go back to the document. So I've given you some examples to look at. I explained that this would not be the same molecule, right? This would actually not balance out. You wouldn't have a molecule like this. Okay, so if you hit the checklist and you're looking at this, you understand that you can do the name, right? You're just taking the name of the cation and then adding the name of the polyatomic ion. You can write a balanced net charge zero chemical formula. Again, the only sort of tricky piece is maybe whether or not you have to add those parentheses. Now remember, you wouldn't add the parentheses if they balance out, because I don't need to add the parentheses. Oops, sorry. I don't need to add the parentheses in our first example, right? I can just write this NaHCO3. That's balanced, although that pension is awful. So you wouldn't need to put parentheses here because it's one hydrogen carbonate, okay? Just wanted to point that out. So the question I'm asking you guys to fill in is to name 2 compounds, iron, right, with the anion chlorate, right? Chlorate is right here in the table with iron. I've given you iron as a cation with a +2 charge and a +3 charge. So remember, iron is a transition metal. It's here, 26. So it can have different charges. So what I'm asking you to do is give me the name, right? And then there are 2 different names. So that you may want to look back at part 1. Okay, so there's 2 different names and then 2 different chemical formula. Okay, so think about what's different about naming the transition metals when they form cations, and you should be able to fill this in. Okay, that's it. All I'm asking you to do is write those things and turn those in along with everything else. You don't have to update the resource, okay, unless you want to with these rules. That's totally up to you. But I just want you to understand how we name with polyatomic ions. All right, that should be it. Hopefully that's not too much.